Welcome to our lecture on the time value of money. Now, the time value of money is super important to all financial planning, whether that's for companies or individuals. The time value of money lies at the heart of it all. It's the concept that makes all of finance work. And it's always there. It's always in the background, even if you don't realize it's there and it's playing a role. So since it's so important, let's go ahead and look at what it is. So to understand the time value of money, let's refresh a little bit about the financial planning life cycle. This was discussed in lecture number 1. Now remember, in the financial planning life cycle, we're trying to maximize our lifetime satisfaction from money, and we're going to do that by spreading our money out. So we're not spending all of our money in a short period of time. We got to live a nice, consistent lifestyle. Right? And so if you remember, we do that by pulling some money forward in time. We call that borrowing. We're going to take money from our future, bring it into the present, so we can spend it today. That's borrowing. And then saving is taking money we have today and we're going to push it off into the future. So we can spend it later when our income falls, when we're retired. So that's the financial planning life cycle. And if you notice, what's happening here is we're moving money through time. Borrowing to pull it forward through time, and saving to push it off into the future. That begs the question then, is this a good idea? Do we want to do this? So let me ask you a question to think about then as you're moving your money through time. Would you rather have $1 million today or $1 million in 30 years? Think about it. Probably didn't take you very long to answer, did it? Everybody answers this question, I'd rather have the million today. I've never had a student say, I'd rather wait 30 years for my $1 million. We all would rather have it today, wouldn't we? That feeling that tells you, I'd rather have money now than later, that feeling in your head is the time value of money. It tells you money now is better than money later. It's hardwired into who we are. We'd rather have it now than later. And there's a number of reasons for that. Okay, inflation is one reason. Inflation is the tendency of prices of things to rise over time. And so $1 million in 30 years will not buy you as much stuff as $1 million today will. So that's one reason to get it now. It will actually buy you more stuff. But that's actually the smallest reason. More importantly is $1 million today, you can use it now. There's no risk. You don't have to worry about it disappearing. You have it in hand. So you could invest it and make more off of it if you had it today. Or you could pay off your loans and not have to pay interest on the loans. Or you could just live better now and live $1 million if you are smart about it. Would easily last you 30 years. So we would rather have it now. Now what if I mix it up though? That was kind of an obvious one. What if I mix it up? Would you rather have $1 million today or $100 million in 30 years? Okay, surveys of people, when they're asked this question, about 10% of people would rather have the 100 million, but most people would still rather have the 1 million today. So this says something. So now we're getting more dollars in the future, and more dollars in the future might be enough to sway us away to say, you know what, I don't know, I think I'd rather just kind of wait. Okay. The main principle of the time value of money is that $1 today is worth more than $1 tomorrow. And the further in the future you're going to get that dollar, the less valuable it is to you. It's still $1, still just $1, but you would rather have it now. Its value to you is higher in the present, and it gets less and less and less in the future. That's the time value of money. And so when you look at this question, $1 million today or $100 million in 30 years, it's not so clear because now you have more in the future. Is $100 million 30 years from now, is that worth more to me than $1 million today? And for some people the answer will be yes. For some people the answer will be no. What determines that is based on their psychology, who they are, their preferences, and to an extent their circumstances as well. For someone who already has plenty of money and they're living comfortably and they don't need any more, they might just wait the 30 years. But for someone who's broke and just paycheck to paycheck and struggling to get by and worried about making rent every month, the $1 million today is a lot more valuable to them. Okay, so we have ways of estimating this and figuring out which one is better for us using time value of money formulas. Okay. Now let's do one more example. Would you rather have $300 a month now or $500,000 in 30 years? Think about it for just a second. Was this one harder? Is the answer as easy for you to find? Most people find this to be a lot harder to find an answer to. They have to think about it a little bit. Now, if this seems like an unfair question, you're like, well, these are two different things, $300 a month and $500,000 at once. Those are kind of different things. And Dr. Payne, this is not a fair question to ask us. But this is exactly the question that every single person faces. Because if you invest $300 a month for 30 years, you will have $500,000 in 30 years. And so that's the question you're going to face in your financial planning life. Now, no one's going to ask you that question. There's not a multiple choice exam that it's on. But that's what it works out to. Would I rather have my money now, $300 a month now that I can spend on groceries and vacations and whatever I like? Or would I rather save it? And if I give up my $300 a month now, that means I can't spend it now. I can't spend it now. I'm saving it. I'm pushing it off. So it's like it's gone. It's like I never got it at all. But in 30 years, I'm going to have $500,000 in my retirement account. That's the question we all face and have to answer. And the problem is people are answering this question without even knowing that the question has been asked. They don't know that it's been asked, but it has. It's the reality of planning for the future. So that feeling in your head that tells you money today is better than money tomorrow, right? I'd rather have $1 million today than $1 million in 30 years. That feeling is the time value of money. Now, if you Google time value of money, you'll find a lot of formulas. And you're like, this is all math. And Dr. Payne said it was a feeling. What's going on? Those formulas are a way of capturing that feeling in numbers. Okay, we're capturing that feeling in numbers, and then we can do some calculations, and then we can compare. Should I take the $1 million today or the 100 million in 30 years? You can use the math to help you answer that question. Okay, so let's talk about how. Now, we're not going to go through the time value money formulas. They're pretty complicated. Fortunately, you don't have to do that, right? You got your Texas Instruments BA2 Plus financial calculator. And it's going to do all the work for us. It's our friend. Okay? It's going to do all the work for us. So you don't need to worry about the formulas. Okay? All you need to do is follow this process I'm going to outline in this video. And it's also outlined in detail with practice problems in the workbook. So make sure you check out the workbook. But I want to walk you through this a little bit. So there are 5 components to every time value of money problem. Okay, first is present value. Now be careful here. Present value does not refer to the value in the present. It doesn't mean today's value. Present value means the value at the start of the period in question. Now, in a lot of problems, the start is today. It is the present, but not always. So let's say, for example, your question is, your grandma invested $1,000 for you to go to college when you were born 20 years ago. How much is it worth today? That $1,000, even though it's in the past, is your present value because it's your starting point, your start value. Okay, so I apologize for the confusion in terminology. I didn't invent the terminology. I don't know who did. But don't get confused. Present value means the start value. And I'm saying this many times because this is a problem students have frequently. Okay, so I'm repeating it a lot. Present value is the start value, not necessarily the value in the present or today. Now, likewise, future value is the ending value, not necessarily the value in the future. So to go back to our example, your grandma invested $1,000 for you 20 years ago. What's it worth today? The what's it worth today is the future value. Even though today is the present, in that problem, you're going to solve for the future value, the value at the end of the 20-year period. Okay, so present value is where you start. Future value is where you end. Payment, PMT, repeats. That's how we can tell a payment from a present or a future value. Payments happen every month or every year. So you pay $500 a month rent. You earn $6,000 a year in interest, right? It doesn't matter if it's every year, every month, repeating over and over and over. It's a payment. Payments happen between the present value and the future value. Okay, so for example, let's say the question is, your grandma invested $1,000 for you the day you were born, and then gave you $100 every year on your birthday for 20 years until today. How much is in the account today? Okay, the $1,000 is your present value. It's before the first payment occurs. The payment, the $100 a year, is the PMT. And students often get confused. They're like, well, okay, so she paid $1,000 into the account, so that means $1,000 is the payment. No, the payment repeats. Your present value is not $1,100 because present value is before the first $100 payment gets made. Okay, but payments repeat. That's your key to determining, is this number a present value, future value, or a payment? If it's repeating every month or every year, it's a payment. No ifs, no ands, no buts. Always a payment if it repeats. IY is the interest rate per period, not necessarily per year. And in fact, in this class, we're going to use interest rate per month in our calculations. However, interest rates in this class and in life are always given per year. So if I tell you the interest rate is 6%, that means 6% for the whole year. And then you're going to need to break that up into monthly interest rates. The interest rates are always given to you for the entire year. So keep that in mind. And then lastly, N is the term or the number of periods, number of years, number of months, right? How long between start and finish? How much time is there between present value and future value? How many payments are happening, right? You have a present value, you have N payments and a future value, and an interest rate that happens over all of that time. Okay, those are the 5 pieces of the time value money puzzle. You're going to be given 4 of these pieces, and you'll need to calculate the 5th. Now, if I don't give you a number in a problem, like I say, your grandma saved $1,000 for you 20 years ago, what's it worth today? I didn't tell you a payment in that problem. There's nothing repeating. If you don't get a number given in the problem, then it's 0. Your grandma didn't make a payment every year, and that's why there's no payment. That's why it's 0. All right, those are the 5 pieces of time value of money. So here are your steps to solving all time value money problems. Okay? No matter what the problem looks like, no matter its shape, if it's a problem that involves a present value, a future value, and a payment, if you have money over time flowing, it's a time value of money problem. And you just need to follow these 4 steps. Okay, so no matter if you don't feel comfortable with math, you're like, oh, I don't know, I struggle with math. It's all right. Come back and follow the 4 steps. You don't have to understand the steps. You don't have to know what they're doing. You just need to know what they are and how to do them, and it will always work. It'll always work. Just follow the steps. Step 1, identify all pieces of the puzzle. Write down on your paper future value, present value, payment, IY, N. Write them all down, and then go to your question and pull the pieces out and say, okay, here's my present value, here's my future value, here's my I, here's my N. All right, I guess I'm solving for payment. Okay, write out the pieces though so you know what they are. It's easy to get lost in these problems. It's very easy to get confused or mixed up because there's quite a few numbers you got to put in the right place. Do yourself a favor. Trust me, write them down. Step 2, determine the sign. This is going to be the hardest step. So present value, future value, and payment can be either positive or negative. Now there's no such thing as negative money, so why are these dollar amounts positive or negative? Well, it tells the calculator which direction things are flowing. So if you are taking money out of your wallet, pull it out of your wallet and sending it away, it's negative. Now, it doesn't mean you're losing the money necessarily. It can still be your money. But if it's pulling out of your wallet so you can't spend it, pulling out of your wallet, I can't spend this anymore. I'm going to send it off into the future. I'm going to send it off to the bank or whatever. Even though it may still be your money, right? I'm making a payment on the loan, that's not my money anymore. I'm sending it out to the bank. But if I'm putting it in my retirement account, I'm depositing it, I own the account. It's still my money. I haven't lost any money, but I've lost the ability to spend it. That's a negative. Conversely, money that's coming towards your wallet, you're going to be able to spend it, is positive. So when you borrow money, let's say you borrowed money for a house. Let's say you borrowed $200,000 to buy a house. The $200,000 is going to be first a present value because that money comes to you at the beginning of the loan. Beginning of the loan, the bank sends you $200,000 and you're going to go buy a house with it. So the bank sends you $200,000. That's a positive $200,000. Doesn't matter that it's debt, right? It being debt doesn't make it bad, and that doesn't make it negative. Which direction is it flowing? It flowed into my wallet so I can go buy something with it. That makes it a positive. If I'm pulling money out of my retirement account so I can go buy groceries and Christmas presents for the grandkids, that's a positive. It's coming into my wallet for me to spend. Again, this is the most complicated part, but keep that picture in mind. Did it come into my wallet or out of my wallet? That's your key. If it was into your wallet so you could spend it, it's positive. If it's out of your wallet and you're not going to be able to spend it right now, it's negative. Even if it's still your money and you haven't lost it. Step 3, we're going to convert all time periods to months. So interest rates are going to be given to you per year. So if I tell you 6% per year is the interest rate on your loan, let's say, for example, you're going to take that 6% and divide it by 12 to get an interest rate per month. If I tell you 8% per year is what your retirement account earns, then you're going to take that 8% and divide it by 12 to get 0.75% each month. Okay, so your interest rate, you're going to divide it by 12 to get interest rate per month. Your N, if I tell you you invest for 25 years, you're going to multiply that by 12 to get the number of months. If I say you save for 2 years, how much do you have at the end of 2 years? You're going to multiply 2 by 12 to get 24 months, right? So you're going to have an interest rate per month and number of months for N. And then your payment needs to be payment per month. Now, most of the time, like 90% of the time, your payment is already going to be payment per month. You pay $300 a month on your car loan, you pay $1,500 a month on your mortgage, right? Lots of the payments that we do in financial planning already happen per month. But if you happen to get one that's per year, just convert it to payment per month by dividing it by 12. Okay, come back to this point in the lecture if you need to in the future. But remember, interest rate divided by 12 to get per month, and times by 12 to get number of months. And if your payment is per year, given to you per year, then divide it by 12 to get you the number, the payment per month. And our step 4 is you're going to pop that information into your calculator and hit compute, and it will do all the work. Okay, so identify the pieces, check your signs, convert to months, and calculate. Those are your 4 steps. So let's do an example. We're going to solve for the future value in this question. Here's the question. If you invest $500 today at an interest rate of 6.5%, how much will you have after 5 years? So let's go through our steps. Step 1, let's identify our pieces. Okay, future value is what we're solving for. See how it says how much will you have after? That after is your cue. Oh, at the end of 5 years, how much do I have? That means I'm looking for future value. Let's go through the rest. Do we see any dollar amount repeating? Do you see anything per month, anything per year? No, right? There's no dollar amounts repeating. So our payment is 0. Our present value is going to be the $500. That's what we're starting with, right? We're going to start with $500, and after 5 years, how much will we have? That's our question. Interest rate is 6.5%. That's usually pretty easy to find. It's got a percent sign in front of it, so it's usually pretty easy to spot. And our N is 5 years. Again, that one's pretty easy to spot too. It's the only one that's a unit of time, right? 5 years is our N. That's step one. Step two, let's check our signs. So we have the $500. That is going to be negative. Why? Because we're going to take $500 out of our wallet and send it into the future. Now, we haven't lost $500. It's still our money. It's just in a different account. So don't get confused. It's not like the negative doesn't mean it's lost. The negative means we're pulling it out of our wallet and sending it away. We're sending it to ourselves in the future. So it's still our money, but we're not going to be able to spend it today. And that's what I mean when I say take it out of your wallet. We lose the ability to spend it. So we're not going to be able to spend it today. So that's going to have to be negative then. Step three, let's convert to months. So our 6.5%, we're going to divide by 12 to get 0.5417% per month. In this class, we'll round our interest rates to 4 decimal places. So that just makes sure we all get the same answer. It's nothing special about that. But if you set up your calculator following the instructions in the workbook, it will automatically show you the 4 decimal places, and you'll be good to go. And then our N, we need to convert 5 years into months. So we're going to multiply the 5 times 12 to give us 60 months. So we're going to earn 0.5417% per month for 60 months. And then we're going to press compute future value on our calculator. And there's a video on Blackboard showing you how to click the buttons. Okay. If you need help with that. So we're going to hit compute future value. And when we do that, we get a future value of $691.42. Okay, so go ahead and try that and see if you can get it before we move on to the next problem. All right, let's try one more example. How much should you pay for an investment that pays $50 a month for 10 years, assuming you want to earn a 12% interest rate? All right, step one. Let's identify our pieces. Future value. Is there any money at the end of 10 years? No, there's not. It doesn't say you'll get or you'll pay anything after 10 years. There's none of that, so there's no future value. The payment is going to be $50 per month, and we know the 50 is a payment because it repeats. $50 every single month is what you're going to get. Because it's repeating every month, it must be a payment. What we're solving for is our present value. All right, how much should we pay today at the beginning of the 10 years? What should we pay if we want to earn 12%? So our interest rate is 12% and our N is 10 years. So now we've got our 5 pieces. Step 2, let's check our signs. Okay, so the payment, $50 per month, does that need to be positive or negative? It's going to be positive because you're going to get that money, right? The investment is going to put money into your wallet every month for you to spend. So that makes it positive. All right, step 3, let's convert to months. So we're going to take our interest rate divided by 12 to get 1% per month, and our N times 12 to give us 120 months. And when we hit compute present value, it gives us an answer of negative $3,485.03. Now, that negative is fine. Present value, future value, payment, those numbers can be negative and it's not a problem. If you calculate a negative interest rate or a negative N, then something has gone wrong. But when your calculator gives you a negative number out for future value, present value, or payment, it's just telling you the direction of flow. So let's think about it logically. If you're going to buy this investment, what are you going to do? Where's the money going to flow? You're going to take money out of your wallet, right? And send it out. You're going to buy an investment with it. So you're sending money out at the beginning of the 10 years, and the calculator is giving you a negative sign on your answer to indicate that. So that's the time value of money, the principle, the concept, and a couple of examples for you. go through the workbook. There's lots of practice problems, full solutions, as well as just the answer for you to work on and practice. And then there's another video by someone else on YouTube that has a good, that walks you through actually using the calculator and the mechanics of it if you're struggling to figure out which buttons to push.